Hey guys, Mr. Riz here to help you, or I guess to explain this giant packet that you guys got. So you guys probably just got this big packet here. It looks pretty thick, but I'm going to go through right now to kind of explain some of the assignments that you guys will be working up to kind of have this activity after Chapter 2 in Algebra 2. So this packet you can see is broken up to a couple different assignments here. There's the first assignment, which is the City of Vancouver's water consumption graph and questions here. You can see 6 points here. When you guys get that done, just let me go through, I'll grade it, I'll initial it when you get it done to kind of keep track of things. You technically don't need to have my initials, but it's a good way since you guys will be turning in this packet all at once. But if you want to keep track as you go through this packet, have a little count, be like, okay, did I get that done? Did I get that right? And then I'll put your score here. The next one, we're looking at the average cost of items from 1997 to 2017. I found some information, put a big chart on there for you. Then we move on to lines of fit. There's the lines of fit activity that you guys will do. We have a couple bit of notes in there before that. That's a 4-point assignment. And then the next couple assignments are fairly larger and they should take you a couple days to do. There is an assignment building off the lines of fit called The Thief at the Museum. I'll go through and read that with you guys later on in this video to kind of explain what you guys will be doing in that project. And then there is a scatter plot correlation and lines of best fit exam. Since this is kind of wrapping up one big section, we're working on this together. This is almost like an open note partner take home test that you guys can have and work on as you guys complete this packet here. All right, so first off with scatter plots, that's good. We got a couple different things that we can do here. Scatter plots have 3 different types of correlations, or at least right now, linear correlations. There could be a positive correlation, and the easiest way I like to look at that is if the dots tend to move up or like have a positive slope, that's a positive correlation. It doesn't need to make a perfectly straight line, but in generally, does it move up going from left to right? On the other side, we have negative correlations. Those move down going left to right. So does the graph generally go in one direction? And then no correlation would be all over the place. So some ways to think about positive correlations could be like the number of followers on an Instagram page and the number of adorable puppy videos that are posted. The more puppy videos that are posted, typically the more followers you get. You probably could replace puppy with another word or some other things, but yeah, you know how. The more you post, the more followers you get. All right, negative correlations could be like the more missing assignments you have, your overall math grade tends to drop. Now, some people can miss a lot of assignments, but still have good tests. So it's not a perfect correlation, but it's generally in that direction. And no correlations could be like the number of koalas in a zoo and the number of keychains sold in a gift shop. So it really doesn't matter how many koalas you have. I don't think that's going to affect your keychain sales. If it does, I'd be surprised. Okay, so in this first activity that you guys are going to do, we have some information about the City of Vancouver and its water consumption. All right, so in this assignment, you guys will create a line graph to illustrate the City of Vancouver's water consumption from 2006 to 2015. All right, so in this packet here, I have some real data from the City of Vancouver. All right, I got there's some graph paper on here, some discussion questions, and then some other things that you guys will see here. But the water usage data, there's no answer key. I guess I took that off the packet. But this data is going to range in values from 480 to 583 liters per person per day. So this activity kind of gives us an opportunity to talk about the axis break and what we'd want to do so we don't have to start so close to zero. All right. So in this assignment, what you need to do first is, given this information here, you're going to put years on the x-axis. So you have this graph here. So you want to go ahead, put years on the x-axis down here. All right. Then you're going to put the amount of water consumed on the y-axis. So that's going up and down. Okay, so you label your axes. All right. Then what we want to do is make sure we have all these other features. You want to put a title to this graph. So don't just leave it blank, but up here, label, give it a title. You can just call it the water consumed by the City of Vancouver in liters per day. All right. You have your X and Y labels. You have labels on your X and Y axes. All right. The numbers on the X and Y axes are appropriate. So if we're looking at years, you're probably not going to start with 0, 1, 2, 3. It'd be kind of hard to see what Vancouver's doing in the year 10 AD, but maybe you change those to more appropriate numbers. Same thing with the y-axis, you know, do you need to start at 0? If we look at these numbers are not really close to 0. You go through. So what you're going to do here is you're going to pick these data points here. Now notice some of them don't actually have available points, so you won't mark those on the graph, but you plot those points on the graph, and then you're going to connect the dots to the best of your ability, and you're going to look to see what kind of correlation they have. You guys will then answer these questions here. So why will you want to use an axis break along the graph? So an axis break is just a split in the numbers showing that, okay, you're not starting at 0, you're going to start at a different number. All right. Why might there be information missing between 2007, 2008, 2009? So what could have happened that make these numbers not appear? Think about it. Might have to Google some things or take a good education guess. All right, how do we make the graph when we are missing data? So what should you do if you're missing data? All right, what trend do you see with this graph? How has the Vancouver's water consumption changed during the 10-year period? What might you expect the water consumption to be in Vancouver today and why? So if you had to guess, and tell me why. And how much water do you think the average person uses in your city? Maybe you have to look that up. Okay, so that's assignment 1. Not too bad. Plot some points, get a graph, answer those questions. All right, assignment 2 here is this giant table of information. And this is basically the average cost of items from the year. I didn't put the years, or the years got cut off. Basically, it's the year 1997. So that's up here at the top, going down here to the year 2017. What I want you guys to do here is pick a category, and you're actually going to find 3 categories of one thing that has a positive correlation. So that means the numbers tend to be going up. Have one that has a negative correlation going down, and one that has no correlation, meaning it didn't really matter throughout the years. All right, you are going to each one of those. So positive correlation, if I think food and beverage has a positive correlation, which it kind of does. All right, you're going to graph that information here on a chart. So you'd have to label your axes. All right, then what you're going to do is complete the table. So tell me, okay, what is your X? What's your Y? So you're making X years, Y the price, or vice versa. And then based off of that graph, predict what the price of that item would be in 2023. So as you look to see at the trends, try to take a guess of where that would be. So you're going to do that for positive, negative, and then also for no correlation. Okay, moving on to lines of best fit. This is actually where we can start doing some math here. So lines of best fit is something that we can do to actually help us further predict like the best possible answer, to get a better, closer approximation. So lines of best fit typically go through and they give us an estimation of what the overall chart is going. So we could go through each one of these here and I could draw a line of best fit. Now notice here with lines of best fit, sometimes you have points above, sometimes you have points below the line, sometimes you have points that are right on the line. Typically what you can do is you can actually pick 2 points to go through and go through. Now, like I'd probably pick like this point and that point to use here to make our line of best fit. I definitely want to be like, oh, maybe this point and this point would be the 2 I'd want to go through. Because if I did that, this line here definitely does not predict the overall trend. There's actually a thing called a correlation factor, which is a really fancy math term, an equation you can use to find the best correlation, which 2 dots match up the best. Good thing we have computers that can do that automatically for us. Now, sometimes our lines of best fit won't work. So if I try to make a line, okay, this would work here at the beginning, but wouldn't work at the end, or vice versa. And even that. Now, there's actually more than just lines of best fit. There are other things called curves of best fit. Like this would make a really nice parabola, but we're just going to leave this one blank because we're not that or in that type of mathematics yet in Algebra 2. Maybe later on in the year, we'll get to that. All right, so we're going to go through this first part together in our notes here. So if you're in this part, let's kind of talk about this. If we're looking at lines of best fit here, what we can do here is first to see, okay, how many data points do we have, or how many data points go through the line? All right, I would say it looks like that point definitely does, and I would say that point does. You might argue, okay, that one does, but let's say that we have 2 points here that go through those lines. And what are the coordinates for those 2 points? Now, if I had to guess here, the 1 point is at like in between, well, more than 3, less than 6. So I'd probably say that's at like 1, 4. And this one here is probably at 5, 15. So using some other information here, filling out this table here, our point 1 we can say is 1, 4, and that's our x1 and our y1. And our point 2 is at 5, 15. We've done this in chapter 2. We can find equations of lines using y equals mx plus b. We first have to find our slope, which is our y2 minus y1 over x2 minus x1. So if we plug those numbers in, see, we would have 15 minus 4 over 5 minus 1, and that'd be 11 over 4. Okay. So that is our slope, 11 over 4. Or if we wanted to, kind of use a decimal, I don't like to. You can say 2.75. I don't even like to write that, but okay. Point slope, we're not going to use that, but we could use slope intercept form at the bottom there to figure out what the equation of this line is. So we just take one of our 2 points. I really like this 515 here. That's nice there. And we're going to plug this in. All right, so y equals mx plus b. We have our y is 15. Our m is 11 over 4. Our x is 5. We're going to solve for b. You know what? Let's just use decimals here, make our life easier. All right, so if we take 11 over 4 and we times it by 5, that's why we have calculators. 55 over 4, which is 13.75. And if we want to solve for b, we subtract that 13.75. And we would get 1.25. All right, so our final answer equation line would be y equals, let's use decimals here, 2.75 x plus 1.25, which kind of makes sense because if we kind of look here, where does it start? I'd say that actually starts pretty close to 1.25. All right, so what we can do is, this is called a line of best fit, and we can use this to predict other values. So maybe we could predict the length of the CD if we have 12 songs, because all we would have to do is to take our equation and plug in 12 for x, and our y we would get would be the length of the song. All right, so the one thing about this is it isn't too bad, but we can actually get better if we use Desmos here. So I'm going to show you guys an example here. I'm going to split screen, pull up Desmos. You can technically do this on a graphing calculator. It's just not as neat as Desmos. So we're going to just use Desmos here to get us started. So what we're going to have to do first is we're going to have to use a table to type in our x and y. So if we have this apples and weight here, we're going to make a table, and you'll click the plus sign and then go over here to do tables. And you're just going to type in our x's, let's say would be our apples. So 0, 1, 2, 3, 4, 5, 6 there. And then our weights are our y's, so 0, 0.8, 1.7, 2.5, 3.1, 3.6. All right, so generally that makes a straight line. It looks like it's a little dipped, but we can have Desmos here try to figure this equation out. So if we do y sub 1 and then do this little squiggle line, mx sub 1 plus b, what that actually does is really complicated math. It goes through the dots and try to find out the best dot possible. And it actually tells us our parameters here of what our m and our b should be. And that's listed down here in the bottom. It says our m is 0.73. We can just go to the second decimal point. It even goes further. X plus our b here is 0.1. 1. Now this R squared tells us the correlation to this. So basically how close we can get. 1 would be perfect, but 0.8 or 0.98 and 0.99, those are actually pretty good too. All right, if you guys want to try this next one on your own, do that, but I'm going to kind of go through and explain the rest. So we'll finish off our notes here and then I'll tell you guys the other assignments. All righty, so let's change the table. We got 9, 10, ooh, 9 again. Ooh, I'm kind of messing up here. Gotta delete these things. Oh no, delete, 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 delete. 12, 11. So these are ages and shoe size. So 9-year-old wearing 6.5. I'm assuming these are probably all the same gender. 8.5, 7, 8, 7.5, 9. Cool thing about this, if you did this on Desmos, is that it actually goes through and adjusts your line as each point gets plotted in. And you can see here, oh, that one's actually pretty good. Not perfect by any means. You can see definitely we have some outliers here. This 10-year-old has very large feet, I guess, bigger than the 13-year-old, but you know, it happens. All right, so the equation would be y equals 0.45x plus 2.95. And we could use that predict, you know, what a 14-year-old should be wearing or what a 60-year-old should be wearing by plugging in that number, that age for x. Okay, so going back to our assignments here, the next assignment, the third assignment is you're going to look at this table. I know this is sideways, but what you're going to do is you're going to put these dots in, you're going to plot those on your chart here, and then you're going to pick 2 points. You're going to determine the slope and determine the y-intercept, and then get the equation of that line. You're going to use that then to predict the amount of fat grams for a food item that has 350 calories. So you can use your chart or you can use the table here to kind of figure that out. All right, this fourth assignment here, you guys are going to go read through this, but basically you guys are going to have to do your own investigation. So I'm going to have some things set up for the room here. But what happens in the story is a thief breaks in and steals a piece of art. And the security system noticed that the person has to like jump or step over the first 7 feet. And they have these 5 suspects, but they're wanting to try to figure out who it would be. And they're trying to figure out if there's some mathematical correlation between their height and how far they can jump. Well, obviously we don't know these people, you know, having them jump, but what we're going to do is we're going to collect our own data here. So what you guys are going to do is you guys are going to measure each other's height. So I will have some, you know, tape measures up. You're going to measure your height, and then we're going to measure how far each person can jump. So we're going to work as a class together, and we're going to gather that information. We're then going to plot that information onto our chart here and try to find a linear regression. So try to predict how far each person jumps based off their height. Then once we have our graph, our linear correlation or a line of best fit, we're going to plug in each person's height. So Jan is 5'7". We're going to plug in their height and try to predict what their distance would be. In the end, you are then going to write up a report to try to give your best explanation of what the thief was. So big thing here is I'm going to be looking, okay, did you collect the data in terms of height of the table? You got it all plotted out the right way, X's and Y labels wrapped out or labeled appropriately. You got the line of best fit using Desmos here, and you found the correlation, and you got a good line of best fit to determine. You use that line of fit to determine how far each person can jump, and then you're going to go through in your report. So you're going to say who the thief was. You're going to thoroughly explain all the steps used to make that conclusion. So how did you determine that person was the thief? And then you're going to use the interpretation of that correlation coefficient and what it means for the strength of your argument. So basically, you're going to use this correlation number to say like, okay, if that's a number close to 1, definitely almost 100% certain that that person is the thief. Now, if your correlation is like 0.6, then maybe you're only 60% sure. Okay. And then the last thing is the exam. These are just basic questions here going over that you can use to predict, and you guys can work together on this. So I know this seems like a big assignment, but we'll be working on this for several days in here to kind of wrap up chapter 2 and kind of build some other things. As we move out through the year and do some other chapters, we're going to take time to always go back and try to relate this to other activities and other labs, not just do tests and worksheets in this class. All right, guys, have a good one. Thanks for watching this video. I'll see you later.